Alright, so as requested by the class, folks were asking me to show how you would do from practice problem B on page 128, how you would do number 3. Well, as it turns out, as a more recent request that I've gotten, I already uploaded a video here to the channel that's showing you how to do the last problem on our more recent assignment, which is Newton's second and third laws. And that was that last equation with, again, a sailboat in that problem. And they had a force to the north and a force to the east in this case. And we had to take it a step further, not just finding the net force, but the net acceleration. So this problem is going to be a lot like that problem too. But I'll show you real quick how we're going to be looking at this diagram here, right? How it's going to be looking. So again, this is from the what's this assignment called? Newton's first law, and it's number 3 again from the practice problem B, page 128. So we have our sailboat here, okay? And our sailboat is experiencing a force to the north, which is equal to 452 newtons, and it's also experiencing a force to the west, which is equal to 325 newtons. Alright? And what they're wanting us to find is the magnitude of our net force. So, magnitude of the net force, they just want some number. And they also want the direction. So that means the relative angle theta that we're dealing with here, okay? So, first things first, to find that, this is going to need to require vector addition. So we're going to take these vectors and put them together. So we have our force to the north, and then we have our force to the west, and our net vector, or our resultant vector that we're looking for, would be right here, force net, okay? And our angle theta would be located right there. Now, since we know this side of our triangle and this side of the triangle, and this is a right triangle, by the way, since it's north and then west, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, all right? And we can substitute our variables in for a and b being our force to the west squared plus our force to the north squared equals our c. So it has to be the hypotenuse of your right triangle, which would be our net force squared. Now this is going to require it's going to require algebraic manipulation since this is squared to get it by itself. So I'm going to go ahead and do that step for you here, right here and now. So the square and the square root gets canceled, and whenever you do one side of the equation, you have to do the other. So when we rewrite it, our net force, and I'm just flipping the equation too, is equal to the square root of our force to the west squared plus our force to the north squared. Okay, so that's going to help us solve for the magnitude. Now for the direction, well, check it out. I know this side, I know this side, and I could solve for this side. Remember, whenever you have the option to solve for a particular unknown or variable using only given variables, do it that way. So we want to use the opposite side and the adjacent side. So when you look at SOHCAHTOA, tangent is the opposite and adjacent. So tangent theta, and I'll just go ahead and put it down here then so we can still see our triangle. Here we go. So tangent theta equals opposite over adjacent. So when we plug in for our variables, it's tangent theta equals our opposite here is our force to the west, divided by adjacent is our force to the north. Now we're going to need to use algebraic manipulation here because we're solving for this guy. So we need to, because it's tangent times, or being multiplied by your theta, your angle, we need to divide by tangent, and that'll cancel out. But whatever you do to one side of the equation, you need to do to the other. And remember, when you're dividing by tangent, it's the same as multiplying by the reciprocal, and you can also rewrite it like this, where theta equals tangent to the -1 power, negative first power. That's the same as 1 over tangent, the inverse or reciprocal of tangent, okay? And that's being multiplied by your force to the west divided by your force to the north, okay? And so this is the equation that will help you solve for the direction, and this is the equation that will help you solve for the magnitude. Now remember, when we give direction, it's not just some angle. We're going to need to give the relative angle. Always, always, always. So you can't just say, oh, it's like 15 degrees. I'm going to need it to be specific. Now, if that way's north and that way's west, this is going to be some angle theta west of north. Again, this angle needs to be written out as whatever that angle is, west of north. You'll write that in your answer if you wish to receive full credit, on top of doing the unit analysis steps, which you'll have to do yet next to make sure your units work out, and then substitution, your solution. Okay? Great. If you need more help in that, just come in and see me, and I'd love to work with you.